Good morning, grade 10. In this video, we are going to start a new chapter. It's chapter 16, and it talks about forces. So, you have an idea about it from previous classes. What is force? The force is any action that tends to maintain or change the motion of a body or its shape. So, whenever you see something trying to change the motion of an object, to stop it, to make it move, to make it speed up or slow down, or even to change its shape, we have a force. It can also be defined as the interaction between objects with mass which results in a push or a pull. Force can affect motion in several ways, as we already said. First, they can make the object start moving. They can make them move faster or move slower. They can make them stop moving, and they can make them change the direction. This is concerning the motion of an object. If it's not only about motion, a force can also change the shape of an object. Okay. The SI unit of force is the Newton, N, defined as the amount of force needed to make a 1 kilogram object produces an acceleration of 1 meters per second square. All forces have 4 characteristics. First, the point of application, in the place where the force is applied. Second, the line of action. It can be horizontal, it can be vertical. If it's not horizontal or vertical, as we will see later on, it will be making a certain angle with the horizontal. 3, the direction, to the right, to the left, up or down. And 4, the magnitude or the norm or the size of the force. Now, how do we represent a force? We use an arrow to represent a force. As you can see in these two figures, whenever you have a force, we can represent it using an arrow. Okay, if the force doubles, then the force arrow should be twice as long, because the length of the segment representing the force represents as well the magnitude of this force. So if you have F of a certain length and you need to represent 2F, the length of 2F should be double the length of F. So the length of the force arrow corresponds to the magnitude of the force. Now, if the push wasn't directly to the right, but instead he made a 30-degree angle with the ground, as you can see in the figure. In this case, I have to represent the force with this direction, making 30 degrees with the horizontal. So we need to change the direction in which the force is applied. It's not always horizontal, not always vertical. Sometimes it's making a certain angle with the horizontal. Drawing a force diagram. A force diagram is simply a diagram showing all the forces acting on an object, because as you all know, most of the times I don't have only one force acting on an object, I have more than one force acting on the object. So to represent that, I have to use a force diagram. So the force's direction and the magnitude should be represented in this diagram. It is a simplification of the picture that shows just the forces. Okay, we will take this example. In the example below, the first image is a picture of a climber on the side of a cliff. As you can see, this person is trying to climb on the side of the cliff. The second image shows just the object of interest, and it's only the person without the cliff and with the forces acting, and has vectors drawn representing the different forces on the climber. The third image is a force diagram. So whenever you are asked to do a force diagram, you have to do something similar to the third image. So the object of interest is simply represented by a dot. We don't draw the whole person, it's only a dot. And then the vectors are labeled by the type of force, and the object exerting the force and the object receiving the force. So the green one is friction of the cliff. You can simply write Fr. The brown one, it's the pull of the rope, and the gray one is the push of the cliff, and the blue one is the pull of the gravity. So this is what we call a force diagram. Okay, now I have two types of forces. One, contact force. Forces that act through direct contact between the two objects. Example, applied forces and friction. The two objects applying the force on each other should be in contact with each other. The second one is long-range forces or non-contact forces. These are forces that can act over distances. Example, gravity and electromagnetic force or EMF. How do force combine? More than one force often acts on an object. When all the forces acting on an object are added together, you determine the net force of the object. An object with a net force more than 0 Newton will change its state of motion. Okay, so let's take another example. In this photo, I have more than one force acting on this person. The total combination of the forces is called the net force. So here I have 1, gravity is pulling you down to the earth, and 2, the ground is supporting your legs, and 3, your legs are moving you forward as you run during a physical education. Now, what I call balanced forces is when you have the net force equals to 0. As you can see in the first figure, I have two groups of students. Each one is applying a force of 400 newtons backward. So the sum of these two forces is equal to 0 Newton, so I have balanced forces. In the second figure as well, I have 50 newtons up and 50 newtons down. When you add them together, you'll get 0 Newton. So I have balanced forces. A balanced force is one in which the net force equals 0. Examples, we already done that. Now, unbalanced forces. An unbalanced force is one in which the net force is greater than 0. So, in this case, I will have a motion. As you can see, I have two groups. It seems that the purple group is applying a force less than the blue group. The purple group is applying a force of 25 newtons and the blue group is applying a force of 14 newtons. So, if you add them, you won't get 0 Newton. This is why we don't have balanced forces. So, the force produced by the blue team is greater than that of the purple team. So the net force is 50 Newton. Because we subtract them, we will take that later on. That would tip the ropes direct to the right. Now the other example is, I have these two people. I have 50 Newton down, which is their weight or the gravity force, and 2 Newton up, which is the air resistance. So the air resistance will negate 2 Newton of gravitational force, which will leave 48 Newton of net force, pushing the skydivers to the ground. Okay, so only an unbalanced force can change the motion of an object. Example, your dog can cause you to move if it pulls with enough force. Its force is greater than the force you're using to stay in place. This is why you will be moving. Okay, unbalanced forces can act in the same direction. Example, you're pushing a cabinet across the room with a force of 15 Newton and your friend is pulling it with a force of 10 Newton. You are both acting in the same direction. So what is the net force? In this case, you add them. So it's 15 plus 10 equals to 25 newtons to the right. When two forces move in the same direction, the forces are combined, and here the net force is 25 newtons. Here as well, I have approximately the same example. When forces are applied in the same direction, they are added to determine the size of the net force. I have 25 newtons to the right. I have 20 newtons to the right. One of them is pushing, the other one is pulling. The sum, the net force, is the sum of these two forces, which is 45 newtons to the right. Now, forces in different directions. I have 10 newtons to the left and 12 newtons to the right. So the net force in this case is going to be the difference between them because they don't have the same direction. We do 12 minus 10, you get 2, and the direction is that of the bigger force, which is 12 newton. So it's 2 newtons to the right. So when two forces act in opposite directions, you subtract the smaller force from the larger force to determine the net force. The net force will be in the same direction as the larger force. Example, 10 Newton plus 10 Newton, both of them to the right, you get 20 newtons to the right. 10 Newton and 10 Newton to the left, 20 newtons to the left. 10 Newton and 10 Newton, one to the right and one to the left, you'll get 0 Newton. If the forces aren't collinear, we use the parallelogram rule for addition of vectors. You know the parallelogram rule that you take in math. So, let's see. This is the first force, and this is the second force. These two forces aren't collinear. I cannot add them the way I was adding the previous forces. So, to find the net force in this case, you complete the parallelogram, which is this is parallel to the second force and this is parallel to the first force, and you match the diagonal. So the red line represents the net force of the blue force and the black force. And that's it for now. We will complete the lesson in another video. Thank you.